Hey everybody, Mr. Troy here. You are not going to believe it, but we are nearing the end of the year. This video, solving sine equations that are more challenging and solving tangent equations, is one of the last videos that we're going to have for the entire year. And then it's summer, and then you'll get to be at your houses doing what... Ugh. It's time for math with Mr. Troy. Alright folks, this video is going to be super bare bones because I just want to focus on really simple things. First, equation. The tangent of theta equals 1. For the life of me, I don't know why that equation is so small. There. How's that? That better? Okay. So where does the tangent equal 1? Well, let's take a look at the unit circle. On the unit circle, we have two ways of thinking about the tangent. One of the ways of thinking about the tangent is thinking about the slope of this ray, because it's y over x for the tangent. So from the origin, y over x would be the slope. The other way is thinking about the ratios. When are the y and x values the same? So that occurs in two places, and those places are directly across from each other, a straight angle across the origin. Okay? So, because of what we've talked about, because of the graph, the period of this is going to be pi. So your general solution for this equation can be pi over 4 plus pi n. Of course, for n is an element of the integers. If you say pi over 4 plus 2 pi n and 3 pi over 4, sorry, 5 pi over 4, what am I thinking? Plus 2 pi n, that is unnecessary because that doesn't tell you any extra information, and it takes you two sentences. So, don't want to do that. So our general solution is just going to be this one thing. So pi over 4 plus 0 pi n is here. Adding 1 pi would be back down here. Adding another pi would be over here. Adding another pi, another pi, another pi, another pi, another pi. So that is our general solution. That is how tangent equations differ from sine and cosine equations, because their period is different. Okay. So here's one where we would need to use a calculator, and we'll do that in just a second. If I'm looking at this using that same thought from before, I'm kind of asking myself, where is the slope of this ray equal to 4 over 1? Is it there? Is it here? Is it something like that? So that we're going to need to get out of the calculator. Movie magic while I get it out of the calculator. I tried to do the snap thing yesterday, and it didn't work, so I'm going to try and get out of the calculator. The calculator says it's 1.33. So 1.33. Now, that's in radians. So what I did was I did the tan inverse of 4, and I got 1.33. That's in radians. Now, if you want to know what that is in degrees, you know how to convert that to degrees. So I just did that, and I got basically 76 degrees. Now, we're going to use this right here, this 1.33 radians. That's the rounded answer. But just so you know, it would be at about 75 degrees. So we can get rid of this one. The first one was closer. Remember that the other place would be just across the origin, something like that. That ray would also have a slope of 4. So our general solution, super simple, would be 1.33 plus 2, no, not 2 pi, I even got me, 1.33 plus pi radians. And we would throw in like a little approximately there to show that that's not exactly correct. but that's just about right. All right, so here's our last equation. There's an easy way to think about this, and there's a hard way to think about it. I think thinking about it the hard way is really important, but we're actually going to skip that right away. For those of you who are like, well, you got to tell me, here's what I'm talking about. This function has its period 4 times as narrow. So its period, instead of being 2 pi, is going to be 2 pi over 4, which is pi over 2. That's going to come up later. But that's the hard way to think about it. Here's the easy way to think about it. The easy way to think about it is just to come up with a general solution and then work from there. So the general solution would be that, well, where does the sine of something equal 1/2? Either at pi over 6 plus 2 pi n, or at 5 pi over 6 plus 2 pi n. Now, that would be the solution for the input or the argument to the sine function, which means that's solving for 4 theta minus 3 pi. And I don't want to solve for 4 theta minus 3 pi. I want to solve for theta. So I need to add 3 pi to both sides. So that's going to be 19 pi over 6 plus 2 pi n equals 4 theta. Or 23 pi over 6 plus 2 pi n equals 4 theta. Okay, now why did I add that to only the pi over 6? So this is the pi over 6, and this is the 5 pi over 6. Because that's what you do when you solve equations. If I had this, and I wanted to add 7 to both sides, I would only add 7 in one place, not in 2 places. Now I'm going to divide by 4. So my two solutions are going to be 19 pi over 24 plus pi over 2n equals theta, or 23 pi over 24 plus pi over 2n, pi over 2n equals theta. And this is, of course, for n is an element of the integers. Okay. The more challenging way to think about it is to think about the fact that the period has to be pi over 2, but you're way better off to just set up your general solution and then solve for theta. We'll do some more of those later, but that was just to get you started. All right, folks, hang in there. The end is near.